All right, so let's do some examples of sketching polynomial functions by hand. Okay, so of course you can use Desmos to verify, but on a quiz or test, I would ask you to perform the analysis. Okay, so in your homework, right, it's going to say use the leading coefficient test, find the zeros, plot sufficient solution points, and then draw a continuous curve. All right, so the first thing I recognize is that this is an intercept form, right? And so in order for me to use the leading coefficient test, right, it needs to be in foiled form. I don't need to foil the whole thing, right? All I need to do is determine the leading coefficient sign, right? And so when you foil this, right, the leading coefficient, right, is going to be a positive number, okay? And at the same time, right, the degree of this function, right, this exponent right here is a 1, right? This exponent right here is a 2, this exponent right here is a 3, and then remember properties of exponents, right? When you have x to the first times x squared times x cubed, right, you add the exponents. So the degree right here is going to be 6, which is an even number. Okay, so I'm using my leading coefficient test. If a is positive and the degree is even, right, we know it's going to rise on the left and rise on the right. Okay, so there's my leading coefficient test. And then for part B, when you're asked to find the zeros, okay, so I'm just kind of following along in your textbook on problems 85 through 99 odd. I think they asked you to find the zeros, right? And so over here, you could do it in your head, right? The zeros, because it's already in factor form, are just 0, -2, and 1. Okay, now, on this part right here, right, we need to determine the multiplicity, right? So at 0, because the multiplicity is a 1, we know it's going to be a cross. Okay, at -2, I look at the multiplicity, right? It's an even number. It's going to be a bounce. And last but not least, at, oops, that looks really bad. At 1, right, the multiplicity is a 3, so it's going to be a flex, right? So it has a little bit of everything. And if you want to get an extra point, you can try to get the y-intercept, but the y-intercept in this case, if you plug in 0, f of 0 is just going to equal 0. So you're not going to get an extra point. So you could plug in an additional point if you want, okay? So maybe plug in, I don't know, plug in f of 2. F of 2 is equal to 2 times, 4 squared. 4 squared, which is 16, right? I'm just doing some mental math. And then 2 minus 1, of course, is just 1. So over here, you're going to get 32. Okay, so 2 comma 32 is a point on the graph. All right, so let's put everything together. So this is not going to be drawn to scale, okay? So I already know my M behavior, and I know my zeros, right? My zeros are 0, -2, and 1. And I'm going to draw my M behavior. It's going to rise on the left and rise on the right. Okay? Now, when I go from left to right across the screen, the first zero I encounter is a -2, right? But it's going to be a bounce. I'm going to bounce this way. Again, I'm going left to right. And then when I hit 0, right, it's going to be a cross. So this curve is going to come back down. So cross would look something like this. Right? And then when I hit 1, it's going to be a flex. And you're like, what's a flex? Flex is crossing, but it's going to kind of hug the x-axis like that, right? And then, of course, you have some random point. I don't know. We'll call it 2 comma 32 is up here, right? Clearly not drawn to scale. But you can connect it with a smooth, stroke of the pencil, or, I guess you're not using a pen. But there it is. There's my graph. And on a quiz or test, right, I would look at your behavior at the zeros. I want to see the analysis over here, right? If you're crossing, flexing, bouncing. And then I want to see you do this leading coefficient test. All right, so there's example 1. It's in factored form. Well, what if it's not in factored form, right? What if you're given something like, I don't know, f of x is equal to -3x cubed plus 24x squared. Okay, in some ways, it's a little bit easier, right, to do the leading coefficient test because it's already foiled. And so a sub n, we know this time is negative, and the degree of this function, right, is just this big number, right, or the highest exponent, which is an odd number. And so if I ask you what is the M behavior, you would say rise on the left and fall on the right, right? It exhibits the same behavior as -x cubed. Okay, so assuming this is part A, right, the leading coefficient test. Part B asks us to find the zeros, right? So over here, we're going to have to do a little factoring here. I'm going to factor out a negative 3x squared. And over here, what's left is an x minus 8. And so your zeros, if I may, I'm going to rewrite this x squared because the 0 is going to give me a 0. I'm going to write it as x minus 0 squared and then x minus 8. Okay, so instead of setting it to 0, I'm just going to say this is f of x. Okay. All right, so of course you could set it to 0 to find the zeros. The zeros are going to be 0 and 8. Okay, so you have zeros of 0 and 8, right? Okay, now why did you write it like this, x minus 0 squared? Because I needed to determine the multiplicities. Okay, so at the 0, because the multiplicity is a 2, right? It's an even number, it's going to be a bounce. And then at positive 8, we know it's going to be a cross. Why is it a cross? Because the multiplicity right here is a 1, right? All multiplicities of 1 or odd numbers cross the x-axis. And it doesn't look like we're going to get a y-intercept here, but, you know, again, you can plug in an extra point here. I don't know, maybe plug in 1. Okay, so f of 1, negative 3 times 1 cubed is just 1 plus 24. So you're just going to get 21. Okay, 1 comma 21 is a point. And we can sketch it. Okay, so over here, draw the zeros. You have a 0 at 0. You have a 0 at 8. And then what do? You draw the M behavior. It's going to rise on the left, fall on the right, and then go from left to right on your screen. Okay, so at 0, we know it's going to be a bounce. So bounce will look something like that, right? And then when you hit 8, it's going to cross eventually. Right? And then our 1 point was 1 comma 21. So 1 comma 21 all the way up here somewhere, right? 1 comma 21. So roughly this is what your sketch should look like. Okay, so everybody's graph is going to look different, but I'm going to check that you do the analysis if I ask you this question on a quiz or test. All right, so for the very last question, a little bit tricky, but it's good practice, as I always like to say. And actually, this is problem number 92 in your textbook. So again, I'm not making these problems up, right? I'm maybe just doing some even problems here. And I want you guys to try this, okay? So I'm going to give you a hint. You're going to have to factor by grouping. And so pause the video, okay? Don't use Desmos. Try to factor by grouping and see what you come up with. All right, so hopefully you had a chance to try this problem, and you will see that this problem is a little bit tricky, but it practices your factoring by grouping skills. Okay, so over here between these two terms, right? Or actually, before I even begin, let's do the leading coefficient test. Okay, so a sub n is a positive number, and my degree is an odd number, right? Because it's 5. And so you know the M behavior is going to fall on the left, rise on the right, okay? All right, so for part B, right, we definitely need to factor this to get the zeros. Or you could use your rational root theorem, which is in the next section, okay? But I haven't taught it to you yet, and we'll get there, okay? So over here, let's do a little factoring by grouping, as I mentioned. So let me rewrite that function. So I'm going to group x to the 5th minus 4x cubed. And I'm going to group 8x squared minus 32. All right, so between these two terms, right, I can clearly factor on x cubed. I'm going to have an x minus 4. And between these two terms, right, I can clearly factor out an 8. And I have an x squared minus 4. All right. Now, you're like, normally these two terms should be the same. They're not quite, but you can continue, okay? And what do I mean by that? Well, over here, you have an x plus 2 times an x minus 2. And you're like, wait a minute, that doesn't really help me right now. That's okay. Actually, I think I did something wrong right here, right? This should be an x squared minus 4, okay? All right, so x squared minus 4. Let me erase this line. Here's my eraser. Okay, here we go. All right, so in my GCF right here, right, I already have the x squared minus 4. And I'm just going to pull it out. Okay, so x squared minus 4, factor it out, and then you have x cubed plus 8. All right, now, over here, right, this is just simply difference of two squares, right? X plus 2 times x minus 2. Now, hopefully you recall this, okay? This is your sum of two cubes pattern, okay? If you don't recall it, I'm going to give you the formula right here, okay? A cubed plus b cubed, if you factor it, is a plus b times a squared minus ab plus b squared. Okay, so you could look that up anywhere, but that's how you factor x cubed plus 8. So if my a in this case is x and my b is 2, I'm going to write x plus 2 times x squared minus 2x plus, and then b squared, 2 squared, which is 4. All right, so now if you take a look, right, this is actually x plus 2 quantity squared times x minus 2. And the right side of your sum or difference of two cubes, right, this is just not factorable any further, okay? So don't try to factor it any further. It looks very, very tempting. You're like, wait, isn't that x minus 2 quantity squared? No, it would be x squared minus 4x plus 4 if it's x minus 2 quantity squared, right? But regardless, this is your factored form. And now you can figure out what the zeros are. The zeros are negative 2, positive 2, right? And again, this is not factorable. You're going to have a not real answer if you try to use the QF or the quadratic formula. Okay, so don't even try. I mean, you could try to set this equal to 0, but you're going to get a non-real, you're going to get an imaginary solution. So the only zeros I calculate are negative 2 and 2. And why is this step important? I mean, couldn't you have gotten the zeros negative 2 and 2 just on this line right here? You could have, but you wouldn't have known that the multiplicity is x plus 2 quantity squared. Okay? So again, those of you who are paying attention to the details, I might ask you to factor sum and difference of two cubes. I've been known to do that in the past. Okay, so make sure you go back and review. I already reviewed sum of two cubes with you. Difference of two cubes, the sign just changes. This becomes a minus, this becomes a plus. Okay. All right, so how does this help us? On part B, we got the zeros. This will determine the behavior, right? So at negative 2, it's going to be a bounce. And then at positive 2, right, it's going to be a cross because the multiplicity here is just a 1. Okay, so the nice thing about this one, right, is you actually get an extra point. You get the y-intercept. So if you plug in 0 over here, you're just going to get negative 32. So I'm just going to use that as a point. F of 0 is equal to negative 32. There's my y-intercept. You can plug in an extra point if you want, but I'm done with point plotting. Okay, so I have negative 2. I have positive 2. I have a y-intercept at negative 32. Again, not drawn to scale. Okay, so 0, negative 32. There's a point. And we said that the end behavior of this graph, right, is fall on the left, rise on the right. So let's graph that. Fall on the left, rise on the right. And as you go from left to right, right, at negative 2, it's a bounce. So it's going to go back. And of course, it's going to connect to the y-intercept, right? And then at positive 2, it's going to be a cross. So roughly, a graph's going to look something like this. Okay, so the only tricky part about this problem really was just the factoring. Factoring by grouping is one of the skills. And then memorizing this pattern, sum and difference of two cubes. I'm pretty sure you're going to see that over again throughout this course.